How long can a human survive without food? The answer is not a fixed number. It is a biological countdown written in metabolism, energy reserves, and organ prioritization. In controlled medical observation, survival without food typically ranges from several weeks to over a month, depending on hydration, body composition, and baseline health. But what matters more than duration is the sequence of internal failure the body follows as resources disappear. At the moment food intake stops, the body does not immediately panic. Instead, it shifts into a carefully regulated energy redistribution mode. The first 24 hours are powered primarily by glucose already circulating in the bloodstream and glycogen stored in the liver and muscles. During this phase, bodily function remains largely unchanged. Movement feels normal. Thinking remains clear. But internally, the liver is already depleting its stored fuel reserves at a rapid pace. Glycogen reserves begin to run low. The body initiates gluconeogenesis, a metabolic process where it begins producing glucose from non-carbohydrate sources, such as amino acids and glycerol. This marks the beginning of structural sacrifice. The body is now willing to break down its own tissues to maintain essential brain function. Around day 2 to 3, noticeable physiological changes begin to appear. Energy levels decline, physical exertion feels heavier. The brain begins to register persistent hunger signals driven by hormonal changes such as increased ghrelin. Fat metabolism starts to become more dominant, but the transition is not yet efficient. This creates a metabolic gap where the body struggles to maintain previous performance levels. During this stage, water weight loss also becomes apparent due to glycogen depletion, since each gram of glycogen is bound to multiple grams of water. As a result, early weight loss is rapid but misleading. It reflects depletion of stored fuel and fluids, not yet significant fat loss. By day 3 to 5, the metabolic shift toward ketosis becomes more stable. The liver converts fatty acids into ketone bodies, which serve as an alternative energy source for the brain. This adaptation is critical for survival as it reduces the need for glucose and preserves muscle tissue. However, this is not a perfect system. Efficiency is lower, and cognitive sharpness may fluctuate. Fatigue becomes more consistent. Heart rate may decrease slightly as the body attempts to conserve energy. Muscle strength begins to decline due to ongoing protein breakdown for essential glucose production. The body is now operating in a conservation hierarchy, prioritizing brain and cardiac function above all else. As fasting continues beyond 1 week, the physiological strain deepens. Muscle catabolism increases. The immune system becomes less responsive due to reduced protein availability. Electrolyte balance becomes more fragile, increasing the risk of dizziness, weakness, and irregular physical coordination. The body is now surviving, not functioning at optimal capacity. Between 1 and 2 weeks without food, fat stores become the primary energy source. Individuals with higher body fat percentages may survive longer during this phase. But the transition does not eliminate internal stress. Organ systems operate at reduced efficiency. The brain adapts to ketone reliance, but cognitive endurance begins to decline under sustained deficit conditions. Beyond 2 weeks, survival becomes highly variable. The body is now drawing heavily on structural protein reserves, including muscle tissue from skeletal and cardiac systems. At this stage, physiological resilience determines survival outcome more than energy availability alone. Small infections, electrolyte disturbances, or dehydration can become critical. Eventually, prolonged absence of nutrition leads to systemic failure. The heart, requiring constant energy and electrolytes, becomes vulnerable. The immune system weakens significantly. Organ function declines in a cascading pattern. Without intervention, the body can no longer maintain essential life processes. Survival without food is not a simple measure of days. It is a progressive dismantling of biological systems, each stage marked by adaptation, sacrifice, and eventual exhaustion. The timeline varies, but the sequence remains consistent. Depletion of glycogen, transition to fat metabolism, protein breakdown, and finally, systemic collapse. In essence, the human body is remarkably resilient. But its survival without food is not indefinite. It is a temporary negotiation with its own reserves, one that inevitably reaches a biological limit.